Hello. Welcome to This is Mathematics for SHS1, brought to you from the Center for National Distance Learning and Open Schooling. I am Betty Osei. This is the first in a series of lessons that we'll be having on this program. In this lesson, we are going to tell you about the history of numbers. And the title is the real number system. Real not because the numbers are living, but because we use them in our everyday real life. We are going to look at rational numbers, irrational numbers, and again, rational and irrational do not mean what we have in ordinary and everyday English language. We will also look at some examples of these types of numbers and work some questions. By the end of this lesson, we should be able to classify numbers under various subgroups under the real number system. Now, can you imagine what the world would be like without numbers? Can you imagine using telephones or cars without numbers? Numbers are very important. So, what do you think a number is? A number is an idea of a quantity. It is represented by symbols called numerals. For example, the numeral 2 represents an idea of two quantities or two mangoes. Now, there are two main groups of numbers. We have the real numbers and the complex numbers. But this lesson focuses on real numbers. I want you to come with me. We are going to put up a building of numbers. We will start from the base and then we will build upwards. Now, when counting started, people counted their possessions and objects. And so they started with numbers like 1, 2, 3, and so on. And these numbers are called the counting numbers or the natural numbers. There are so many. And normally we use the capital letter N for them for short. Now later, when people started giving out things and deducting from what they had, they got to a point where they had nothing. So the idea of 0 was added to the set of natural numbers. And that gave us a set that is called the whole numbers. Now, whole numbers are written with capital W for short. These are natural numbers together with 0. So they start from 0, 1, 2, 3, and so on. Remember, we represent them with capital W for short. Again, as people continued counting, they realized they had to borrow from friends or borrow money from money lenders. And so there was the need for negative numbers. So the negative numbers were added to the set of numbers that already existed. That gave us the sets of integers. And so integers are numbers consisting of whole numbers and negative numbers. And they are represented as ... -5, -4, -3, and then we go into the positives. So we have 1, 2, 3, and it continues. And normally we classify them as positive integers negative integers, and 0. And this is because 0 is neither positive nor negative. Now, gradually, there was the need for more numbers to be added. And that is because people were sharing what they had with friends. So a new set of numbers, which we call fractions, were added to the numbers that existed. Now, these fractions in maths are written in the form A over B. And this set of numbers is what we call the rational numbers. Now, the A represents any number called the numerator, and the B represents any number called the denominator. Note that B should never be equal to 0. So, for example, -3, half, 3 over 5, 1.5, and all such numbers are rational numbers. All integers are also rational numbers because they can also be written as 4 over 1 or -2 over 1. Now again, fractions can be expressed as decimals. For instance, half is equal to 0.5. 2 over 9 is equal to 1.666, and it continues. And we have decimals that either terminate or repeat, or those that do not repeat or terminate. Examples are the ones you can see. The set of rational numbers is written with capital Q for short. Now, in addition to the numbers we have looked at so far, there are another set of numbers. These numbers cannot be written as a fraction or in the form A over B. In decimal form, they never end and they don't repeat. And such numbers are called irrational numbers. Irrational numbers. An example of an irrational number that cannot be written as a fraction and it never ends or repeats is the square root of 2. The square root of 2 is equal to 1.41, and it goes on. You can see it on the screen. And that is an irrational number. And that means that its decimal goes on and on and on forever with no repeating pattern. And square root of numbers like 2, 3, 5, 6, 7, 8, 10, 11, 12, 13 are all irrational numbers. But remember, just the mere fact that we are saying the square root of something doesn't mean that that number is irrational. Example, the square root of 4 is 2, so it is not an irrational number. The square root of 25 is 5. It is not an irrational number. The square root of 36 is 6. And the cube root of 8 is 2. All these numbers are rational numbers. But the square root of 2 is an irrational number. There are other special numbers which are also irrational numbers. Another one is pi. I'm sure you have heard of pi. This is the number we use in calculating the area of a circle, which I'm sure you met in your JHS class. And pi is also equal to 3.145, a very long fraction. It doesn't end. It doesn't repeat. Pi is equal to 3.14159, and it goes on and on. It doesn't terminate. It doesn't repeat. Now, all the numbers we have looked at so far form what we call the real number system. And I want us to look at the building we have put up. This time, we will start from the top down. We have the chart on the screen for you to follow. So going over the chart together from the top, we have the real numbers, and this is represented by the letter R. The real numbers is broken down into two groups, rational and irrational numbers. We are going to look at the rational numbers first. Under the rational numbers, we have the integers and fractions. And the set of integers is broken down into two other sets, negative integers and whole numbers. The fractions are also broken down into two groups, which are finite decimals and recurring decimals. Then under the whole numbers, we have 0 and the set of natural numbers. Now, on the other arm, from the real numbers, we have the set of irrational numbers. Irrational numbers are numbers that go with the square root sign, which we call sets, or the special numbers like pi. Now, this is like having a whole country, and then you have smaller regions, and then further, you have smaller districts, all under the country. You need to study this chart and understand it very well. Now that we have done so much on the groups of numbers, we want to try a few questions. I hope you have your pen and your paper and your calculator. If you have one, listen very carefully and try to answer the questions along with me. Question number 1. It says, pick the integers out of these numbers. And our numbers are 1 over 5, 2.87, negative 101, 0, 540, and negative 2/4. I hope you have finished. I got 3 numbers, and I hope you also got 3. Now, the set of integers has to do with complete objects. So 1 over 5, which is a fraction, cannot be an integer. Again, 2.87 cannot be an integer. So the first integer is negative 101. 0 is also an integer. And the next one is 540. That is also an integer. The number negative 2/4 is also not an integer. So our answers are negative 101, 0, and 540. I hope you got your answer correct. Question 2 says, match the groups of numbers with arrows. And we have group A, which is made up of counting, whole, integers. And group B is made up of negative 5,896, 0.35, 0, 9 over 10, and 23. When you look at these two groups, and I hope you have tried your hands at them, counting numbers, whole numbers, and integers all have to do with whole objects, complete objects. And so for our answers on the right, you must match them to only whole numbers. You cannot have fractions or decimals. And so for counting numbers, we have 23. So your arrow must go from counting numbers to 23. For whole numbers, your arrows must go to 0 and 23. And then integers should go to negative 5,896, 0, and 23. I hope you got them correct too. The next question says, tell which of these two is rational and why. The first number is 783 over 0, and the second number is 7 over 10. Now, if your answer is 7 over 10, that is correct. And that is because the first number, 783 over 0, even though it's a fraction, has 0 as the denominator. And we said fractions cannot have 0 as the denominator. So it cannot be a rational number. The other number, which is 7 over 10, is a fraction. And it doesn't have 0 as the denominator. Good. So we have learned so much in this lesson. We have looked at types of numbers. We looked at counting numbers, and we said they are numbers that begin with 1 and go on and on. We saw whole numbers that start with 0, 1, 2, 3, and continue. We saw the set of integers that are made up of negative whole numbers, 0, and positive whole numbers. And so we have negative 3, negative 2, negative 1, 0, 1, 2, 3, and it continues. We also looked at rational numbers. And we said they are also fractions. And they are written in the form A over B. And the B should not be equal to 0. Again, we mentioned irrational numbers. And those are numbers that are not rational. Finally, we said the real number system is made up of rational numbers and irrational numbers. Now, all too soon, we have come to the end of this lesson. We have learned so much. Take your time, go over them, and make sure you join me for another interesting lesson on real numbers. So expect more of such interesting lessons. Join us again. Bye-bye.